Bismillahirrahmanirrahim. Dear students, last time we started chapter number 16, which is about the hydrocarbons, and today I will discuss these three topics about the alkanes and the cycloalkanes. So first I will discuss the nomenclature, means naming of the alkanes and cycloalkanes. Then I will move towards their physical properties and then their chemical properties, means their reactions. So first about the nomenclature. Nomenclature means naming. So we have to give the name to the organic compounds. There are two ways of the naming of the organic compound. One are called as the common names and second are called as the IUPAC names. So common names are little bit are there some for some molecules. For example, N-butane, isobutane, N-pentane, isopentane, neopentane. And when increasing the number of common atoms, there it is hard to give to the common name. So we give the IUPAC names. So there are some rules for giving the naming to the organic molecules. These are called as the IUPAC rules. So I will discuss those IUPAC rules and I will apply on this one of the representative example. So first rule, the major rule is we have to select the longest continuous chain of carbon atoms. So if we have any organic compound having a carbon atom, we have to select the longest continuous chain of the carbon atom. So for example, this is one of the molecule. So there is a chain of the carbon atom. So we can select any one. We have to select the longest chain. For example, this is the 1, 2, 3, 4, and 5. So we have the 5 carbon chain. There is another possibility 1, 2, 3, 4, and 5. One more is 1, 2, 3, 4, and 5. So in either way, we can select the longest chain. So we have to select the longest continuous chain, and now we decided that this is our longest chain. So this is the first rule. In the second rule, after selecting the longest chain, we have to number. So the second rule says the numbering, number the molecule. So the numbering will start from that side where branch is nearest. So you know these are the branches CH3, CH3, these are two branches. So we will number from that side where substituent means branch is the nearest. So it means if in this molecule there are two possibilities. If we move from the right, this will be 1, 2, 3, 4, and 5. It means when we move from the right side, the branch comes at carbon number 4. But if we number from the left side, 1, 2, 3, 4, and 5. So branch comes at the carbon number 2. Means numbering from left is fine. So we will number from the left side. So first rule, longest chain. Second rule, numbering. And the third, name the molecule. So first we will give the name of the branch with the mentioning the carbon number as well. And at the end we will say the parent name. So this is the 5 carbon chain. It means this is a pentane. And it has 2 branches. And both are the methyl. It means it has dimethyl pentane. But we have to mention the carbon number as well. So this did belong to carbon number 2. So this methyl is to carbon number 2. This methyl is also carbon number 2. So its name will be 2,2-dimethyl pentane. So these branches act as an alkyl group. Means methane change to the methyl, ethane change to the ethyl, and propane change to the propyl. So its name will be 2 comma or the hyphen 2-dimethyl pentane. So when there are 2 branches, one of them is a methyl and one of them is the ethyl. So we will write those names in alphabetical order. So ethyl will be preferred than the methyl. So this is one of the example. Next, this is one more examples for the naming. So this is one of the molecule. So we have to decide the numbering from which side we have to give the number. For example, if look at this molecule, if we number from left side, carbon number 1, 2, 3, and 4, It means the branches belong to carbon 3 and carbon 4. If we number from the right side, 1, 2, 3, 4, and 5. So branches start at carbon number 4. So we have to decide the numbering from which side we have to number. So there is another way. We will sum up those substituents. So the branch at carbon number 3, branch carbon number 4. So if we add, the answer is 7. Over at this side, the branch at carbon number 4 and carbon number 5. If we add, the answer is 9. So that side where the sum of those substituent is low, is less, you will number from that side. It means the numbering from this way or the left side is the correct. So its now the name will be 3,4 dimethyl heptane because its main chain is the heptane. So this is one more example. These two examples, if we select the longest chain over this one, so as I have mentioned, 1, 2, 3, 4, 5, and 6. If this is longest chain, the 6 carbons chain, then there are two branches. One of this one, 2 are the methyl, and one is the big branch. This is isopropyl. If we select this longest chain, 1, 2, 3, 4, 5, 6. This is also 6 member, 6 carbon chain, but the difference is there are 4 branches of smaller groups. So this is the methyl, this one is the methyl, this one is the methyl, and this is the ethyl. It means in selecting this longest chain, we have the 4 smaller branches rather than selecting this longest chain having less number of branches and one of them is the big branch. So there is another rule that during the selecting the continuous chain or the longest chain, we will number from that, we will decide that longest chain having more branches. So longest chain with 4 substitute. It means this is our correct decision in selecting the longest chain. So these are two examples for our practice. So this kind of diagram that is called as the line structure. So we will number from the left because the branches at carbon number 2 and both are the methyl. It shows these are the methyl. So its name will be 2,2-dimethyl butane. And this is longest chain 1, 2, 3, and 4. And again they have the 2 branches. So its name will be 2,3-dimethyl butane. So it's all about some nomenclature, and you can find them one, for example, in your book. Then move to their physical properties. We know the alkanes, they all are non-polar. So representative example, they start from methane, ethane, propane, butane, pentane. So they all are non-polar. And in the previous classes, there was a one concept about the intermolecular forces. So intermolecular forces mean the forces of attraction between the molecule. Stronger the attraction, higher the melting point and the boiling point. Similarly, there were different kinds, for example, dipole forces. And one of them was the London dispersion forces, which were present between the non-polar molecules. So these London dispersion forces depend on the electronic cloud or the number of atoms present in a molecule. So these alkane, they are the non-polar, so they have the London dispersion forces. So with increasing the carbon atoms, number of atoms are increasing, so electron cloud is increasing. So when electron cloud is increasing, polarizability is increasing. So intermolecular forces are increasing. So they will change from the methane, ethane, they are the gases. When we move forward, they change to the liquid, and then they have the waxy solid. So with the increase in intermolecular forces, their physical state is changing from gas to liquid and liquid to solid. So we can see over here that the methane to butane, they are the gases. Then carbon 5 to carbon 17, they are the colorless, odorless liquid. The higher member from carbon 18 onward, they are the waxy solid. They are the colorless as well as the order. So they are changing from gas to liquid and liquid to solid by increasing the intermolecular forces. And as I said, these are the non-polar, so they will dissolve in the non-polar solvent. And they are not going to dissolve in the water. So alkane, they are, because they are not going to dissolve in water, so that's why they are called as hydrophobic. Hydrophobic mean water heating. So they are not dissolved in the water. So that's why these alkanes are good lubricants and preservatives for the metals. They keep water from reaching off the metal surface and causing corrosion. So that's why we know that a sodium metal, it is stored in the kerosene eye, so prevent from the reaction. So the next, come to the boiling point of the alkenes. So similarly, as I said, by increasing the intermolecular forces, their boiling points are increasing. So from methane to decane, their intermolecular forces are increasing. So with increasing the intermolecular forces, which are the van der Waals attraction, their larger the molecule, surface area is increased, and greater van der Waals attractions, and that's why their boiling point increases. Generally, by the addition of each CH2 group, increasing the boiling point up to 30 degree till 10 carbon atoms. And if we move the further, mean up to decane, their melting boiling point increases up to 20 degrees in the higher alkane. So the reason is again increasing the surface area, higher intermolecular forces. But this is one of the interesting case. Generally, branch chain alkane, they boil at low temperature as compared to their N alkane. Means if we have the butane and its second isomerase is the isobutane, isobutane will boil at lower temperature as compared to the N-butane. So N-butane has a boiling point of minus 55 degree. Isobutane has a boiling point of minus 10.2 degrees centigrade. So the reason, this is the very interesting, the difference in the boiling point arises because branched alkanes are more compact with less surface area for London force interaction. So with the branching, surface area is decreased and their London dispersion forces, they are going to decrease. So this is the graph. We can see this is the graph for the N alkanes, and the lower graph line, this is for the isoalkane. So then move to the structure of the molecule. So the basic structure, you know, the alkane, the simplest molecule is the methane, ethane, propane, and butane. So in each case, we can see that the carbon is sp3 hybridized. So each carbon is sp3 hybridized, and the general formula for the alkane is CnH2n plus 2. So we have four basic molecules: methane, ethane, propane, and butane, with their boiling points as well. And we can see that their boiling points are increasing. By increasing the carbon atom, so until propane, there is no possibility of the structure. But when we move towards the butane, there are possibility of their second structure, that is called as the isomeric structures. And we know the isomerism, molecule having same molecular formula but different structure formula. So when we have the 4 carbon C4H10, then there are two possibilities of their structure isomers, which are called as the constitutional isomers, N-butane and isobutane. And their physical data is given over here. So this is the straight chain and this is the branch chain. So they have low boiling point as compared to the straight chain. Similarly, if we move to the 5 carbon chain, means pentane, it has 3 possible isomers: N-pentane, isopentane, and neopentane. So by increasing the carbon atom, their isomers are going to increase. For example, for 6 carbon, there are the more isomers, and 7 similarly, and respectively. And this is the physical data about these N-pentane, isopentane, and the neopentane. Now, very important point, or the topic, or the very important segment of this lecture, that is the reactivity of the alkanes. And this might be given a short question. The short question may be discuss the reactivity of the alkanes. And as I said, these alkanes, they are the saturated, so they are very little reactive. They are inert toward the acids, bases, oxidizing or reducing agents, because they all are the saturated. So they are very little reactive. That's why they are called as the paraffins, and they are very inert toward the acid. So we can discuss the unreactivity of the alkane on the basis of these 2 points. Number 1, that is the inertness of sigma bond, and number 2 is the non-polar bond. Inertness of sigma bond means in sigma bond the electrons are tightly between these 2 atoms. So that's why a lot of energy is required to break them. So sigma bond, the single bond is, we are sigma bond. So sigma bond is very stable. So we need a lot of energy to break them. That's why they are not going to easily break. Secondly, because there is no poles. There is no partial positive and partial negative. That's why any other species having negative charge or the positive charge can attack on it. So that is called the nucleophile as well as the electrophile. So moreover, the electron present in a sigma bond can neither attack on the electrophile nor a nucleophile can attack on them. Hence, alkanes are less reactive. So nucleophile is a species having a negative charge, so they will attack on the positive. Electrophile is a species having electron deficient, which is having the positive charge. So because this is a non-polar bond or the stable bond, so that's why nucleophile and electrophile, they are not going to attack by them. The second attached point, as I discussed previously, non-polar. So their bond is the non-polar bond. So electronegativity of carbon is 2.5, hydrogen is 2.1. So the difference is 0.4. So this 0.4 difference is the non. So CH bond, that is a non-polar, and when this is non-polar, there is no poles. So any nucleophile is not going to attack, or they are not going to attack on any electrophile. So it makes very stable. So that's why in view of these things, they are not attacked by the bases, acids, oxidizing agent, etc. But they show some kind of reactions. Generally, oxidation reactions mean if you burn the methane gas, for example, if you have the methane gas, which is generally available in our houses, we are going to burn that one. So this is called oxidation. Or they show some substitution reaction because they are the saturated. So one of the hydrogen is replaced by some other. That reaction is called as the substitution reaction. So that's all about, we discussed about the alkanes. Now move to the cycloalkanes. So they are similar to the alkanes, but they have the cycle, means ring of the carbon atoms. And according to IUPAC system, we will use the word cyclo before writing the name. And it starts from the 3-member ring, means 3 carbon. So 3 carbon we have the propane, but when they are in the cycle form, we will say cyclopropane. So it's named cyclopropane. 4 carbons, this is cyclobutane, and 5 carbon, this is cyclopentane. So these are the basic naming for these cycloalkanes, and each carbon in this alkane, this is sp3 hybridized. Next, if we have some branches over here, so similar to the alkane rule, we will number from that side where the sum of the branches is minimum. So its name is, so this is the methyl and this is the propane, so its name will be methyl cyclopropane. And in this case, this is cyclobutane, and we have 2 branches. This one is the methyl, this is also methyl. So we will number from that side where the sum is minimum. So 1 and 2. So its name will be 1,2 dimethyl cyclobutane. This is 6-member ring. It means this is cyclohexane, and it has again 2 branches, methyl, and this one is also methyl. So 2 way of the numbering. If we number from left, so 1, 2, 3, 4, and 5. So it means the branches will be at 1 and 5. But if we number from the right side, 1, 2, and 3. So this is 1,3 dimethyl cyclohexane. And there is a possibility that some multiple bond, means double bond, are present over here. So we will prefer this double bond. So for example, this is cyclopentane, but they have some double bond. So its name will be cyclopentene because it belongs to the alkene, cyclopentene. There has a 2 double bond, so its name will be cyclohexa. So they are the 6 carbon hexadiene, and we will number 1, 2, 3, and 4. It means double bond are present at 1 and 4 position. This is a similar 1, 2, 3. So double bond present in the 3, 1 and 3 position. So its name will be cyclo 1,3-pentadiene. So there is some naming of these cycloalkanes. And if I move to the physical properties, their properties are similar to the properties of the alkanes because they are again non-polar. They have the London dispersion forces. So they have low melting and boiling points. But the general formula is CnH2n. It means there is 2 hydrogen, they are less as compared to the alkane because they are making the ring. So general formula for the cycloalkane is CnH2n. And if I move to the reactivity, their reactivity is similar as I said about the alkanes because they are the non-polar, and again these bonds are very stable bonds. So some more examples: cyclopropane, cyclobutane, cyclopentanes, and cyclohexane. So we can see the carbon and we are double the hydrogen. There is no plus 2. So carbon 3, 6 hydrogens, carbon 4, 8 hydrogens. Then, as I said about the reactions, so we know that the reactivity of alkane is very less, but they show oxidation reaction, mean burn reaction. You are going to burn this one. And number second, reaction, substitution reaction. So the alkane, there is a possibility that one of the hydrogen is replaced by some other group. So this kind of reaction is called as a substitution reaction, and this is well known example, chlorination of the methane, and this is also given in the 10th class. So if this is the methane, so this one of the hydrogen is replaced with the Cl, and Cl is getting the position. So this is called chloromethane or the methyl chloride. So this kind of reaction is called as substitution reaction. And this reaction takes place in the presence of heat or sunlight. So these 3 hydrogen, they can be further replaced one by one by the chlorine. So in the next step, one of the hydrogen is replaced with the chlorine. This is called dichloromethane. Next, another hydrogen will be replaced by the chlorine. This is called as trichloromethane or the chloroform. And the end, the 4th hydrogen will be replaced by the chlorine, and we get the tetrachloromethane. So this is step-by-step process. So all the hydrogen attached to the carbon, they can be replaced with the hydrogen. So this is called substitution reaction. And this substitution reaction takes place by some special mechanism. That mechanism called as free radical mechanism or the chain radical mechanism. So there are different ways of the reaction in organic chemistry. One is called as the ionic reaction, electrophilic substitution reactions, but this is called as the free radical mechanism, and this is called as radical chain mechanism. So I'm going to discuss one of the example, the reaction of methane with bromine. So this is the example with the chlorine. This is similar to the bromine. So this radical chain mechanism consists of 3 steps. One is the initiation. It means we are going to initiate the reaction. Second is the propagation, means reaction proceed further, and then is the termination. So in the first step, these 2 bromines, so this bond breaks homolytically. We know that here we have 2 electrons. So this bond breaks from the center. So 1 electron goes to each bromine atom. So this cleavage is called homolytic cleavage, and we get this bromine radical. So this is the initiation. So they are going to initiate the reaction. In the next step, this bromine radical react with the methane molecule, and it abstracts one of the hydrogen. So again, this molecule breaks from the center. So this 1 electron and this bromine 1 electron, they make the HBr, and they created the methyl radical. So this is the propagation. So this methyl radical react with another bromine molecule, and again it breaks from the center. So this half arrow shows that it is moving 1 electron, and it becomes a methyl bromide with bromine radical. So this is the propagation. So this is the first initiation, this is the propagation, and then when so this bromine radical can be used in the start for the generation of another methyl bromide molecule. And now the last step, when number of molecules are created, so the last step is the termination. Termination means we are going to stop the reaction. So all the radicals, they combine together and they make a neutral molecule. So there is a 3 possibilities. Methyl radical, make a minus the methyl radical, convert it to ethane, Bromine radical react with the bromine radical, we will get to the bromine molecule. Methyl radical react with the bromine radical and make the methyl bromine. So this is the termination, we stop the reaction. So radical mechanism or the radical chain mechanism or free radical mechanism, it consists of 3 steps: initiation, propagation, then termination. So if we move to summary of this reaction, there are 3, 4, 5 major points. And we know that by reacting the alkane with halogen, we are converted into new class that is called as the alkyl halides. You know, this is the alkyl halide. So the first summary, the substitution of alkane mean RH mean alkane by X mean halogen makes the alkyl halide. RX mean chloromethane and HX just like HCl. And the reactivity means, as I said, neopentane, isopentane, and pentane. So the tertiary means the neo, they have the more reactivity as compared to secondary as well as to the primary. So then if we move the reactivity of the halogens, fluorine reactivity is very fast, very explosive. So we are unable to study this reaction. Then chlorine, then bromine, and this is the least iodine. So generally we use chlorine and bromine for this reaction, which is useful in the laboratory. And as we discussed, that this reaction proceeds via radical chain mechanism. So at the end, as I said, that these organic compounds show some oxidation reaction. So in your book, some definitions are given about the oxidation and the reduction, and these are also given in the previous classes. So oxidation, in simple definition, is the loss of electron. So in organic chemistry, when we are moving more carbon-oxygen bond, means addition of oxygen, we said this is the oxidation. Carbon-hydrogen bonds are decreasing, we said this is the oxidation. Loss of electron, this is oxidation. And special, the increase in oxidation state, we said this is the oxidation. And the reduction is opposite to that. And in simple word, I will say that if we have the methane, means alkane, if we oxidize them, they convert to the alcohol. And we oxidize alcohol, they convert it to aldehyde. And if we oxidize aldehyde, they convert it to ester. So this conversion of molecule from lower functional group to the higher functional group, that is called as the oxidation. And the reverse of that, this is called as the reduction. So these are some definitions about the oxidation and the reduction. So this conversion from lower to higher functional group, that is called as the oxidation. And if we move from higher functional group to lower, that is called as the reduction. So that's all we discussed today. It means we discussed about the nomenclature of the alkanes and cycloalkanes, their physical properties as well as the chemical properties. So if you have any questions, you can ask me in the comment box and we will discuss it. Thanks.